Given a function like y equals 2x plus 1, an inverse interchanges the x and the y values. Let's explore what that means by looking at this given equation. So what I'm going to do is choose an x value. It could be anything, so I'm going to choose x is equal to 5. If you plug that into this equation, you get y is equal to 2 times 5 plus 1. That's 10 plus 1. Okay, that is 11. Nothing really crazy here. It's just that we have 5, and it goes to 11 through this equation. The idea of an inverse is it's a function that takes the 11 back to 5. That is, you started with an x value and went to a y value in the original function. The inverse reverses that for us. So what is this equation and how do we find it? There is a general strategy for it that is pretty straightforward. What you do is you look at your equation. Wherever you see a y, you call it x, and wherever you see an x, you call it y. So in that sense, an inverse is very simple. The equation would be x is equal to 2y plus 1. There you go. I just interchanged all of the x's and y's. But what I want to do is take this equation and write it in a more useful way. And we're going to do that by solving for y. So I got my inverse by switching out x's and y's. My second step will be to solve this thing for y. And this is not very hard to do. I can subtract 1 from both sides, giving me x minus 1 is equal to 2y. I would then divide both sides by 2. And that's it. I have x minus 1 over 2 is y. This is also my inverse, but this is written in a more convenient form. One last thing I'll check is my original equation, this one, took 5 to 11. My inverse equation should take this 11 back to 5. So I just want to check to see if that's true. So I'll take my formula, which is the inverse, and I'm going to put 11 in place of this x. And if I simplify this, I get 10 over 2, and I get 5. So I chose x equals 5, which went to 11. But I could have picked any x value. I could have picked 100 or -1, and this process will always work for this given function. So let's try this process in a couple more examples. So I have y is equal to 1/5 x minus 4. I'm going to start by writing out my inverse, which would be x is equal to 1/5 y minus 4. And now all I have to do is solve this thing for y. I'll add 4. So I have x plus 4 is equal to 1/5 y. And to get y by itself, I'm going to multiply both sides by 5. On the right, the 5 and the 1/5 cancel. And on the left, I can leave my answer as this, or I could distribute the 5 into the parentheses. But in either case, this is the formula of my inverse. So I would say both of these answers are acceptable. And so maybe just one more example that's not as trivial. It's just dealing with a line. Here we have y is equal to the cube root of x plus 3 and minus 2, where the minus 2 is outside of the cube root. So we have, again, my inverse should be x is equal to the cube root of y plus 3 minus 2. Solving for y, I will add 2 to both sides. I get x plus 2 is equal to the cube root of y plus 3. I now want to get rid of the cube root. And we talked about this in a previous lesson where if you want to undo a cube root, you would cube both sides. On the left, I have x plus 2 cubed. And on the right, cubing a cube root leaves me with just y plus 3. I'm going to opt to not cube this out. Instead, I'm going to subtract 3 from both sides of my equation. I have x plus 2 cubed minus 3 is equal to y. Maybe just one final thought here. Had I written my original equation as the cube root of x plus 3 minus 2, there is a notation for an inverse function. And you put a -1 exponent after the f. So it's nothing too crazy here. I called my original function f. So you use the same letter in the inverse. And this -1 exponent means that the formula sitting over here is the inverse of the one that you started with.